and this session is being recorded and it will be available on our website under past webinars by the end of the week. So if you missed any part of it, please check back. And there you are, Brad.
Oh, I've got a nice little spinning bar telling me that nothing's happening yet.
We'll stick with you.
PowerPoint may have just crashed on me. Let me try that again.
Tweet deck. Jorge keeps trying to convince me to use this, but I find it very overwhelming.
It's nice. It's a really, really good thing. All right. Do you have me okay?
Yep, I can see you fine. Nice slide.
Thank you. All right. So how's everybody doing today? Hopefully very good. My name is Bradley Ball, and you're here today to learn about transparent data encryption inside and out in SQL 2012. It looks like the refresh rate is going a little bit slow. Rachel, do you see my slide deck already?
I see you. Yeah, I see your slide deck. I see your little pop-up that you just got.
Okay.
Yep, color scheme, basic.
Okay, excellent, excellent. Okay, so I'm going to go ahead and start clicking through here. So this is me. I've got over a decade of IT experience. Previously, the cool stuff I've done, I've been an EBA for the U.S. Army Executive Office of the President, staff specialist for Publix supermarkets down here in the great state of Florida. Currently, I'm a senior consultant for Pragmatic Works. I've got my ITP in 2005, my TS in 2008. I blog at SQLballs.com. On Twitter, I'm at SQLballs, and my email is bball@pragmaticworks.com. So one of the questions I always get when I do this slide is, why SQL Balls? Well, my name is Bradley Ball, and as you can imagine, as a kid growing up with last name Ball, you tend to get some nicknames. The one that always stuck was Balls. So when I decided I was going to throw in and get involved with the SQL community, it just made sense to me that SQL Balls would be the name that I went after. So if you have a question at all, please feel free to shoot me one on Twitter or shoot me an email or type it in the box here so Rachel can know and can get it to me. But if you want to email and say, hey, Balls, here's my question, just fire away. I'm good to go. So the agenda, what we're going to talk about is why you should use transparent data encryption. How transparent data encryption works, we're going to focus on the Windows encryption model. What is transparent data encryption? What it affects, how it works with advanced features, and how it works with managing certificates. I'm going to plug in a network cable and see if that helps speed some of this up real quick. All right. So the first thing we need to answer is transparent data encryption. There's an additional layer of security. Maybe you need to because you're required by some regulatory or compliance laws. Maybe you got some business requirements. Maybe your boss comes to you and says, hey, I intended this presentation that this guy named SQL Balls did. I think transparent data encryption sounds great. Let's just throw it on everything. Maybe it's customer security. Maybe you're storing secure data with credit card transaction data. Maybe it's bank data with bank account information. Maybe it's something like human resource information for you and your company and your personal information in there. Your customer can vary, but whatever it is, you're looking at a more secure way that you can do things for your customers. But the biggest reason is that sometimes data is missing or stolen. When data goes missing or stolen, one of the big things that you want to be able to do is you want to be able to say, I did absolutely everything in my power as an IT person to be able to prevent this or to be able to keep it as safe as possible. When we're looking at this slide up at the top, I've got these still personal data of 26.5 million vets. We probably all remember when that happened. That was back in 2006. What happened was an analyst for the Defense Department took his laptop home, and it was very, very common practice back in 2006 for people to have copies of production databases sitting on their laptops. And somebody broke into his house, stole his laptop. Well, that's 26.5 million veterans, active duty. You know, no longer active duty, but you're talking generals, captains, you're talking senators, congressmen, regular enlisted folk that are very, very angry at this person and what was happening. And Congress had to send out a letter to all 26.5 million vets and explain to them that their personal data may have been compromised, may have been put at risk. Whenever I hear that story, I always kind of feel bad for that guy, because you know you don't want to be that guy. You don't want this to happen to you. You don't want to be in this situation where you did this. And to make this a little more personal, when I was working for the Army, once I had my laptop stolen. And it wasn't anything where I was sitting there being crazy careless. One of those things where, you know, you always get told, don't leave your laptop in your car. Well, they never say, well, when your 3-year-old is throwing up, when you pick them up from daycare all over the inside of your car, when you get home, you lock the car, you and your 3-year-old inside. Give them a bath, take care of them, give them medicine. You don't sit there and think, oh, I left my laptop out in the truck. I need to make sure and go get that. And so sure enough, it was close to Christmas, and somebody broke into my truck, and they stole my laptop. Now, the one thing that I was lucky on is I didn't have anything on that laptop that could compromise myself or could compromise the mission that the Army was doing. But I still had to go and I had to sit down and I had to talk to the CIO of the base. I had to talk to my manager, his manager, all the way up to VPs in my company, and I know that the Army had to report that to Congress. Now, had I had personal information on my laptop that could have been compromised, I could have been that guy. I could have had a lot of letters sent out. That's not something you want. And in a situation like that, you want to be able to say, I've done absolutely everything I could possibly do to protect myself. Now, transparent data encryption could help with that. It could help if you have things sitting on disk that could potentially have sensitive information on it, just because it's going to make it much more difficult for people to get access to that data. A little bit further down, you can see estimates put the TJ Maxx fiasco at about $4.5 billion. Everything was so bad at TJ Maxx that they actually changed their stock symbol because of that. Maxx, though, transparent data encryption wouldn't have necessarily helped them. The problem with TJ Maxx was that they were using Wi-Fi in their data center, and some unscrupulous thieves pulled up outside of their data center, hacked their Wi-Fi, and were just able to get all the transaction in the clear as they were flying around the data center. Not everything on this list could be helped or prevented by transparent data encryption. However, down at the bottom, Idaho Power says the Mercer breach affected over 35,000 people. Eastmoreland Surgical Clinic burglarized, 800,000 patients' info stolen. That was cases where the media devices where backups were stored were stolen. If you're backing up using transparent data encryption, it would help in those situations. The Eastmoreland Clinic, probably an inside job. Somebody actually broke in and stole the physical device that backups were being backed up to. Idaho Power, that was employee data. 375,000 employees, their personal information from the HR database, the backup just went missing. Oops, we lost a backup. Maybe somebody had it, maybe somebody didn't. Once again, when you're in that position, you want to make sure that you've taken every single step you can to not only protect yourself, protect the data that you're supposed to be residing in. So now let's talk about what is transparent data encryption. Transparent data encryption is a physical database security level encryption solution. It is only at the physical level. Transparent data encryption is meant to encrypt the contents of SQL Server databases on the Windows API storage level. Once we read things off in the disk and they're in memory, they're no longer encrypted. We perform real-time encryption and decryption of data files, backups, every kind of backup, full differential transactional file group, and database snapshots. If the database has transparent data encryption turned on it, when you take a snapshot of that database, the snapshot stored on disk will also be included. This is an enterprise-level feature. If you look at the versions and the compatibilities that are out there, this was introduced in 2008. It's there in 2008 R2. It's there in 2012. This is always an enterprise-level feature. The nice thing is if you're paying the extra money for an enterprise license, you may want to take advantage of this because you've got it for free. Most places, Oracle, Sybase, if you look at a solution like this, it's an extra thousands and thousands of dollars, in some cases hundreds of thousands of dollars. This comes absolutely free as long as you're paying for an enterprise edition license. So now let's talk briefly about what transparent data encryption doesn't do. It doesn't encrypt data after it is read off of disk. If you have access to see it, aka you're a DBA, you're a user with data reader or with DB data reader, the data is unencrypted. If you do a select all and you say, select all from this table and it's got transparent data encryption on the database, you're still able to read it. That's the important thing. This is only about what is stored on disk. Once we're off a disk, it's as if it's completely transparent to the application, which is why it's transparent encryption. It's a really, really nice system. If you ever ask a third-party vendor, is your application compatible with transparent data encryption, and they say, no, it's not, then they're just not educated on what transparent data encryption is. If you can read data out of SQL Server and read contents out of memory, which anything that uses SQL Server can, then you can use transparent data encryption. Now, one important thing to note, file stream data is not encrypted. One nice difference between SQL 2008 R2 and SQL 2008 and 2012 is 2012 you can encrypt full text catalogs. If you upgrade a database and you read it into 2012, you will get the option to rebuild those full text catalogs. When you rebuild them, if you place TDE on the database, they will be rebuilt using encryption. One of the only differences, and 99.9% of this presentation, what you're going to see today, not only works in 2012, it works in 2008, it works in 2008 R2. The only difference is I've got one place in a demo where I would drop the certificate and then I would restart the server. And I would do that to show, hey, you need to be careful, don't let junior DBAs accidentally drop the production certificate, because the next time the SQL service is restarted, all the databases come up in suspect mode. The nice thing is in 2012, they actually prevent that. You cannot drop a certificate if it's in use in dependent parent-child relationship on this object, or this object is being used in a database encryption key, you cannot drop this certificate. So the only difference is what you're going to see today between 2008 R2 and 2012 are full text catalog is encrypted in 2012, and it's not in 2008 R2, and you cannot drop a certificate in 2012, and you can drop the certificate in 2008 R2. So it's a nice little security feature that they added. So you don't want to drop your production certificates. So now let's talk about how it works. The theme of today are questions we were doing beforehand were all Avenger related. Well, that's because I'm a comic book guy. I asked Rachel if she would do that. I love comic books, and they make a lot of sense to me. So as an example, I got my buddy here. This is Colossus from the X-Men. And this is what he looks like when he's doing his normal, average, everyday thing. He's still a gigantic guy. You wouldn't want to mess with him in the back alley. But here he is. This is what he's like when he's a normal human. So his power is, when he turns it on, all of a sudden he becomes this giant steel man, and he's invulnerable to pain. So the reason this is important is this is transparent data encryption. When our data is sitting on our disk in MDF, NDF, LDF files, or if it's our backups or our transaction log backups, then they're vulnerable. But once you turn transparent data encryption on them, then all of a sudden they're protected at a physical level. So let's talk briefly about where transparent data encryption occurs inside of the relational engine. And so what I've got here is a diagram where we've got our user, and we're just going to walk through a select statement within SQL Server. And so our user would fire off a query. It would go through the SQL network interface, and it would go over to the command parser. In the command parser, it's going to, if you've ever gotten a syntax error from a SQL query, you did something wrong, you see the red ink that comes back that says an incorrect statement, that's the command parser's job. It makes sure that we are syntactically correct to be able to build a tree off of the statement. So the command parser will then say, okay, the statement is correct. Let's check in our plan cache and see if we have a plan already drawn up. In this case, we're going to say no. We go through the algebraizer, we have a tree created, we go to the optimizer. The optimizer is going to make a least cost plan, and it's going to hand it over to the query executor. Now each one of these little components, there are day-long courses that are taught about it. So we're not going to deep dive into each one of these, but I just want you to know how transparent data encryption actually affects your system in the context of the select. So our optimizer hands it back over to our query executor. Our query executor is going to basically have a list of here's all the items I need to be able to return this query to our user. And it's going to, in a sense, hand a grocery shopping list to our access methods. The access methods will get that list, and they'll look at the buffer manager, and they'll start calling it out. They'll say, I need this, I need this, I need this. Our buffer manager is going to check in our data cache. And it's going to say, is the data here that we need? Now, for the sake of argument, we're going to say, no, the data is not there. So our buffer manager is going to go over to our encrypted data. And our encrypted data is sitting there on disk. And it's going to read it back in to the buffer manager and pass it to the data cache. At that point in time, inside of the data cache, it is completely unencrypted. So that's where the transparent part comes in. There is no encryption once we get it to the data cache. By the time it's time to use this data within SQL Server, SQL doesn't know that it was ever encrypted. It's only encrypted on the disk. So we'll get that data to the buffer manager, back to the access methods, back up to the query executor, back through the SQL network interface, and back over to our user. And this is how it occurs within a select statement. So how do we implement transparent data encryption? There are 4 easy steps. We create a master key. We create a server certificate, with both of those within the master database. We create a database encryption key within the user database. And we then enable encryption also within the user database. So what are our supported encryption algorithms? We've got AES, 128-bit, 196-bit, and 256-bit. 2012 does not yet have 512-bit AES encryption. I don't know if it's going to be rolled out later in a service pack or how exactly that's going to be handled. But 256 is the highest we can go. You can use 3-key triple DES encryption. And I've got up here cipher blockchain. Cipher blockchain is very important because this is, under the covers, the encryption algorithm that we're using. Cipher blockchain, if you think of a male and a female plug like on an extension cord when you're hanging up your Christmas lights, what it does is it flips the bits and makes each bit pair dependent upon one another. So if someone were to grab one of these files and start trying to hack it and start trying to decode these bits, unless they got every single sequence absolutely correct, the amount of flip bits that we will have within our encrypted files would prevent someone from being able to decode this. Now this is a screenshot right here of our architecture. Now this is a little bit hard to read, but I've got a link at the end where you can go and you can get this chart off of TechNet's website. What happens is we start up at the very top. It's a Windows Operating System Data Protection API. Every time SQL Server is installed on a new server, what happens is there's a data protection API that's laid down. It's a specific machine key encryption file. So that, in turn, when we install SQL Server, there's a service master key, which is encrypted by the data protection API. That is just generated automatically. So later, when we generate our master key in our master database, that master key is encrypted by our service master key, which is also encrypted by our data protection API. When we create our certificate is encrypted by our data master key, by our service master key, by our data protection API. When we create our database encryption key on the user database, that is encrypted by the certificate, by the data master key, by the service master key, by the data protection API. I don't know if anybody out there is familiar with Saturday Night Live, but they did a skit a long time ago called Taco Tim, and it was basically making fun of Taco Bell when they were releasing all these tacos and they were wrapping them in different things. And it starts out with a bunch of guys just eating these regular tacos, and they they say, but wait, there's more, and they wrap them in a flour tortilla with bean dip. And they go, oh, great, but wait, there's more. They wrap them in another tortilla with, cheese whiz. Oh, but wait, there's more. And then they wrap it in another burrito, and then they wrap it in a pizza, dip it in pancake batter, deep fry it, put it in a commemorative tote bag, and cover it in salsa. That is essentially what we get when we look at the encryption keys for transparent data encryption. It's Taco Town in an essence, because it's wrapped inside a layer, inside a layer, inside a layer. If you look at this, there's an EKN module down on the right-hand side that's gray. If you go out and you buy an extensible key management device, I believe they run anywhere from $5,000 to $25,000. It's a very secure machine. It comes with little USB thumb ports, and you basically get an asymmetric key on it and use that then to create your database encryption keys or your certificates, and you bypass a lot of the architecture that's in place. Part of the reason to do that is because those keys are supposed to be so secure. And they may be. I'm not going to focus on using an extensible key management device today. I'm going to focus on the Windows encryption model, because in my opinion, when you have a specific data protection API per server and then a service master key that's specific per SQL instance that are encrypted by one another, that are then encrypting your master key, your certificate, your key, you start to get at a point where, okay, do I really need to pay an extra $5,000 or an extra $25,000 in order to make this more secure? I'm fairly confident that you're probably as secure as you're going to get, considering how specific this is to the machine and to the instance level. So unless your boss or unless your company is just really, really bent on, we need an extensible key management device, I would say save yourself the money and use the native certificates within SQL Server. When enabling transparent data encryption, the time to encrypt a database is based on its size. We're going to see here the demo databases that I have are fairly small databases. They're only going to be about 120 meg that we're going to play around with. If you have a multi-gigabyte database, I think the largest one I've ever put transparent data encryption on is 120 gig. And when I put it on 120 gig, it took about an hour to encrypt it. There's a nice DMV query that we're going to use that I've got a link to Jasper Smith's site. He originally put it out there, and I started using it as well. It's a great query. If you do sysdm execute requests, there's a % complete column in there. There's only a certain number of operations within SQL Server that actually report on that % complete column. Backups are one. Encryption and decryption using transparent data encryption are another one. So the nice thing is when your boss says, let's encrypt this database, using this query I'm going to show you in a minute, if they came to you and they said, hey, what's taking so long? We're 30 minutes in, you could go, well, hey, boss, we're 47.8% through. Hit refresh a couple more times. Oh, look, we're at 48%, 49%. And so that way they know that it's progressing naturally. It's just going to be dependent upon the size of your database. 120 megs, it will be encrypted. Only DDL database file level commands will be blocked when you encrypt a database. You can alter file, that means you should not alter file groups. There's no blocking and locking on user activity. Now is not the time when you're encrypting a database to decide that you want to drop or attach data files. You want to do that either before or after you encrypt. If you have a read-only file group, you're going to need to change that to a write file group because it's going to have to be rewritten to disk. As soon as the encryption operation is finished, you can change that back to read-only. What inherent data encryption? Data files, log files, database snapshots, database backups, full differential file group, and transactional. Now, I want you to notice I've got an asterisk right there, right next to the log files. The reason for that is that our log files are made up of smaller units called virtual log files. Virtual log files written before transparent data encryption is enabled will be in an unencrypted state. Once transparent data encryption is enabled, it forces you to move to a new VLF, and that VLF on open are encrypted. Now, your transaction log kind of works like a merry-go-round. Once those bits are flipped within the virtual log files and they're no longer in use, they will be overwritten. So you'll have some unencrypted sections in your log file initially, but once they get overwritten by natural database activity, they will be encrypted as well. I'm going to go to our first demo right now. What I'm going to do is I'm going to create a database for us to work with. Now, every single one of these demos is up on my website, SQLballs.com. I know SQLballs is going to be really, really difficult thing for you to remember, but go to www.sqlballs.com. I've got a link bar up there at the top that says resources. If you go to my resource page, I've got every presentation that I've done, and next to it, I've got the slide deck and the demos. This is the deck that I used when I was at a SQL rally. So if you go out there, you can get the entire slide deck right now. You can get all the demos right now. But all of this is available to you. So the first thing I'm going to do is I'm going to create my Transparent Data Encryption database. Oh, there we go. Transport level error occurred because I restarted my data, my service after I opened these up. So there we go. We've got our TDE database. We can see it sitting there in SSMS. And now I'm going to create a table real quick. And I'm going to pump some data into this table, and then we're going to go back and take a look at it. I'm going to throw in 15,000 records real quick. And when we take a look at this table, you can see the name of the data is TDE data. We've got an energy identity column. We've got a name text that's fake SSN. We've got an SSN text that's just 111-111-111. And then we've got a default character of A. And so what we're going to do is we're going to back this up, and I'm going to throw this in a hex editor because I want to see you the difference between a backup file when it's not encrypted and when it is encrypted. And so let's back this up real quick. We look over at messages, I've got stats on there for about 10%, so we can see this as it's going along. 10%, there we go. Now we're just chalking right up, 70, 80, 90. We've got it all backed up. So I'm going to go over to my hex editor. Let's see, I got data, let's go to backups, and there you can see I've got TDE unencrypted backup. I'm going to open this up. And now what I'm going to do is I'm going to search for that Social Security string that we've got, 111-1-11. And right away I find it. And this is very, very important to note because when your databases are backed up, normally you would probably sit there and think, oh, it's a proprietary file, it's in there in some jumbled text. Somebody couldn't get my backup and actually read this data off of disk. You would be incorrect. Everything is actually stored in plain text. That is data that you've inserted in your databases. You have Social Security numbers sitting in your backup files. And if somebody dragged that backup file into a hex editor and they did a search, they might not know right away what a Social Security number is, but they could start searching for patterns. If you have addresses in there, you could search for street, way. You could probably find some keys. Maybe you could search on those keys. It would take a little bit of work, but if somebody does get your backup file, they could search and they could start to see, hey, is there anything in here useful? So if I search a couple more times, let's see, I think it's F3 to keep skipping through here. See, my scroll bar is incrementing down ever so slowly. These numbers of my offsets are changing because I'm going to new columns. Because over and over again, I'm finding fake SSN 111. This data is completely and totally exposed. So let's go back over to SSMS real quick. And what we're going to do is we're going to use master, and we're going to create our master key. And it's a very simple phrase: create master key, encryption by password, master key pass1. Now, what I would recommend at this point in time is I love the program KeyPass, keypass.com or keypass.org. KeyPass. There we go. KeyPass.info. There we go. KeyPass is just a wonderful, beautiful little thing that that is absolutely free. And what it does is it manages passwords for you. And Here's a nice little screenshot of it right here. What I like to do is create groups, and I'll make them server names. And every single server that I have a password for, I will sit there and I will put that. I will put that under that underneath that server. So every password I've got an explanation of what it is. I don't have to remember it. KeePass will also generate very, very complex passwords as well. What I would recommend doing is going to KeePass, creating a complex password, and putting it there in any password that's required. So we're going to create our master key real quick. That was completed successfully. And now we're going to create our certificate. Remember, this is step 2 of 4. And our syntax is create certificate, database certificate with subject. Don't put anything important in the subject. And we'll get back to that in a minute, but don't put anything important in the subject. Take my word for it. So we're going to create this, and there we go. There's our certificate. Now we go down, and we're going to use our database we created. Use Transparent Data Encryption. Go. Create database encryption key with algorithm to AES 256. Encryption by server certificate, our certificate we just created, database certificate. As you change that name, change it to whatever you would like. We're going to go ahead and do that. Get a warning. Warning, the certificate used for encrypting the database encryption key has not been backed up. You should immediately back up the certificate and the private key associated with it. So very, very nice error. You should pay attention to this because, in my opinion, once you turn on transparent data encryption in a database, your certificate backups become just as important as your database backups. The reason for that is if you don't have a copy of that certificate, then you might not be able to access that database in the future if you had to restore a copy to another server. So let's turn on encryption. I'm going to alter database TDE. I'm going to set encryption on. I've got to wait for a delay of about 10 seconds, and then I'm going to do another backup. And this is just going to be an encrypted backup. The reason I wait for about 10 seconds is because it takes a second to be able to do it. And I just switched over real quick and ran that script that I was telling you about. And you can see encryption is in progress for database name TDE. At blink of an eye, and you would have missed it, it's already at 100%. The certificate name encrypting TDE is database certificate. Our encryption state is 2 because we're in progress. I just refreshed it, and you can see that the encryption is complete, so our encryption state is a 3. And our backup has happened, so let's go ahead and open up our hex editor again. And this time let's look at our encrypted backup. Now if I do a quick search for 1111-1111-11 for that social security number, it's going to say searching, and then it's going to give us a nice little error saying cannot find 111-111. The reason is because everything is now encrypted, and it's great that we got that error. So let me scroll down so I can find some nice encrypted text for us. And here it is. This is some good stuff. This looks very, very different than what we were seeing. You can see that this file is very much encrypted, and this isn't something that you're going to be able to get access to, and you're going to be able to read it very easily. Now, what I'm going to do is I'm going to make a dynamic backup script real quick. I'm just going to grab this text. I'm going to output it back in our screen. And if we look at the syntax to back up the certificate, it's backup certificate, database certificate to file. I've got a file path where I'm backing it up, and I've also got the name, database certificate 2012-0522.serve. And I do this because I append a date string. I've also got a private key, Brad private key, encryption by password, private key pass1. Once again, I would say if you're going to use this, use more complex passwords, use KeePass, get a KeePass password for what you want your private key to be. We're going to back this up real quick, and it goes in a second. And if I look at of backups, you can see there's my private key, there's my database certificate right there. Now, let's go in the hex editor real quick, and let's open that up, that certificate. Here's our database certificate and our hex editor. And if you look at this text right here, you can see sitting in plain text, because most of the certificate looks encrypted. But don't put anything important in the subject. That's what I was telling you. I was doing a demo once for OPAS, and I had used Brad1 as all the passwords, Brad1 as the subject. And so imagine my surprise when I pull the certificate into my hex editor and I see, wait a second, Brad1 sitting right there. Oh my goodness, I can't believe my password is in plain text in my certificate. Well, it wasn't. I went through later and I incremented everything and I changed it and I found that the subject was in plain text. So I thought, this is rather odd. Why would the subject be in plain text? Because I would think something being called the subject would mean put in here what the certificate is about. That would obviously mean something that you wanted to have that the whole world could probably see. That at least you internally could see, but you probably wouldn't want the whole world to be able to see it. So I did some reading. I went to Books Online and I looked at the subject, and on Books Online underneath the subject it says the subject is governed by the X.509 security standards. That's great. The X.509 security standards are an open source document on basically how encryption should be used and utilized. If you go in the slide deck where you could go and get it if you want, if you're having trouble sleeping at night, I recommend reading the X.509 security standards. Way down in the middle of the security standards, there's information about the subject. And in it, it says that the subject is there specifically so that if two certificates existed on the same server that had the same thumbprint, that the certificate would be, or the subject would be used to differentiate them to make sure that they weren't in violation of one another. So that's all the subject means. So instead of subject, it should have been something like tiebreaker or, uniquify or something like that. This is not some place that you want to put random blank text. What you want to do is, once again, I would take a subject, since this is meant for a tiebreaker, I would put that in KeyPass, and I would generate another complex password, probably 30 characters, just to make sure that it's good and it's long and it's complex. And when somebody comes in here, if they were to get on your server, were to be able to get to your information, they're just going to see more random text and they're not going to think anything of it. But don't put anything sensitive or anything that you wouldn't want the whole world to be able to see in the subject. So we backed up our certificate. So what we're going to do real quick is we're going to detach our database TDE, and then we're going to drop our certificate. So I use master, I drop the database, and I drop the certificate. So now what I'm going to do, SP attach DD is deprecated, so we're going to use the command create database on, and if you look at this command right here, we specify for attach. And we're just going to reattach our database. We're going to attempt to, but remember our certificate is no longer on our database. And when I do that, I get this nice error right here. Cannot find the server certificate with thumbprint and then a nice hexadecimal code. So what this tells us is that we can't attach the database, we can't restore a backup if our certificate isn't there. The reason for this is that thumbprint of that certificate, once we enable transparent data encryption, is actually put in the initial boot file of the database. That means that when we go to do redo recovery, one of the first things we check is in that boot file. And if we don't have that thumbprint, we cannot restore a database. This is what keeps us safe. If somebody steals a copy of your backups, if they don't have a copy of the certificate, they can't restore those backups. They can open them up, they can try and browse through them, but again, they're encrypted. They're not going to be able to get anything out of them. So this is where transparent data encryption comes about. It's a physical data solution only, but this is where we start to get protected. If somebody were to grab a copy of our data, they wouldn't be able to do anything unless they had our certificates. So here's what we'll do. We're going to restore our certificate, and we're going to use the file that we backed up earlier. So I'm going to grab some of this information right up here just to make sure I've got the right certificate. And I'm going to grab my information from my private key to make sure that I've got the right private key. Now, let's look at the statement. Create certificate database certificate from file, or specifying our certificate file with private key, or specifying our private key file, decryption by password. You don't have to use a private key. Private key is a very, very good thing, though, because it's basically encrypting our certificate backups. So if I change this password, I'm going to take the 1 out of there, just private key pass, and I try and restore this, I'm going to get an error. The private key password is invalid. This is good. This is just an extra layer of protection, because let's say someone steals your backup media, and they've got your database files, and they've got your certificates, and they've got your private keys. Unless they have the password to be able to attach that certificate using that private key, they cannot get that far. Your data is still safe. This is where common sense comes in. Once again, I would go to KeyPass. I would make a private key password. I would make it extremely long and extremely complex, and that's what I would use, because it's just there for your safety. So let's put the right password in, private key pass 1. We're going to create our certificate now, and command completed successfully. So now if I go back up to the top and I try this attach command again, I can see the command's completed successfully, and sure enough, my TDE database is there. Now, I'm going to do what I told you about earlier. The big difference between 2008 and 2012 is you can't drop the certificate if it's in use. So let's drop our database certificate real quick, or at least attempt to, and we get this nice error. The database certificate cannot be dropped because it is bound to 1 or more database encryption keys. This is a great improvement. It was a lot of fun for demos to be able to drop the certificate, restart the SQL service, and see everything come back in suspect mode, because that's a big wow moment. But to be dead honest, I would never want the capability to drop a certificate that's being in use in an environment. That's just a recipe for disaster. If somebody drops that and you go days, weeks, months before you reboot your server, and then you reboot it and you can't bring it online, that's a giant problem when all those databases are in suspect mode. All right, let's back to our demos. Now what we're going to do is, oh yeah, that's the drop. We fixed that. So now let's unencrypt. If we take our Transparent Data Encryption database and we say, okay, I wanted to play around with encryption in our dev environment. We're not going to go with it. I'm going to turn TDE off. Okay, so how do you do that? Alter database TDE, set encryption off. Very, very simple command. And if we click enough, there we go. You can see decrypting in process. We were able to catch this while it was only 40.3% done. And that's the beauty of this script. Encrypting or decrypting, you can use it to be able to see what's going on in your server. So our encryption state is 5. If we refresh this again, we should be unencrypted. There we go. Encryption state 1, unencrypted. Now, you may be looking at this and going, okay, we're unencrypted. I've got other databases on this instance. Why aren't they showing up? It's only showing up if there's an encryption key associated with it, but we're unencrypted at this point. But we have not dropped our database encryption key. So to truly be able to get our database off our list, we need to go back and we need to drop the database encryption key on database TDE. And that's just another simple command. Drop database encryption key. So let's run that. Run our script again. And you can see that our TDE database is no longer showing up. Now, what's interesting is what's still on here is our temp DB. As soon as you turn on Transparent Data Encryption, the temp DB is encrypted. And so until you restart SQL Server, because every time you restart SQL Server, the temp DB is destroyed and recreated. Until you restart it and that temp DB is destroyed and recreated, your temp DB is still going to be in an encrypted state. So what does TDE affect? Temp DB. We just took a look at that. We just saw once you turn it on, temp DB is encrypted, it stays encrypted. I've heard about people, I've seen conversations at least, where somebody reported that if you have temp DB encrypted on an instance and other non-encrypted databases working with it with the performance fit. I've scoured the web for this. I saw somebody state it once on a forum. I've never found anything to back this up. I think it's important to mention it just because if you do have an issue like that, I'd love to know about it. I'm sure there's people at Microsoft that would love to know about it. It's a warning that was put out there, but there's never anything I found to back that up, because that's always a question. What if my TempDB is encrypted and I have a couple databases that are encrypted, a couple that aren't? I don't think it's going to impact your performance. And then again, maybe if you have a very, very high OLTP system where your CPU is at 80, 90% level, I mean, just screaming fast, thousands of transactions a second, maybe you would see some overhead. This is where doing a baseline testing in a dev and a staging environment are very, very important before you would move something like this to production. Instant database file initialization is a beautiful and wonderful thing. It was introduced in SQL 2005. You make sure that your SQL Service account is an administrator on the box, that it has performance volume maintenance tasks, group policy permission granted to it. And what it does is it allows it to skip out the zeroing of MDF files, either on creation, auto-grow, or on restores. It is a wonderful, wonderful technology. But if you turn on transparent data encryption, you have to zero out encrypted MDFs. You have to zero out encrypted backup files. So you can no longer skip this step. So if you're using instant database file initialization, and if that's a big benefit to your production environment, you'll have to take into consideration that you would no longer have this if you put on transparent data encryption. Backup and recovery strategies. Like I said earlier, the second you start using CDE, your certificate backups are just as important as your database backups. If you're going to back up and restore to another box as part of COOP or your disaster recovery policy, that certificate must exist on that other box in order for that backup to complete successfully. If you refresh your your dev environment with your prod environment, that production certificate must exist on your dev environment as well for you to be able to do a backup and restore on that. If you're just doing something like pumping out data using SSIS or replication, that's not a problem, because remember, once we read it off a disk, once it's in memory, it's completely unencrypted. It's only if you're actually going to do a redo recovery kind of scenario or use backup and restores that you would need to have the certificate in multiple locations. But if you do that, I've been at places where they want a different certificate for dev, for their staging environment, for the production, and for the COOP. You can have multiple certificates on an instance. However, production database backups, if you want them different on every location, you need to have that production certificate on each location. You need to restore the backup. You would drop encryption, and then you would re-encrypt with that new certificate. Your maintenance strategies. You need to be backing up your certificates. They're only small 1K files. I've gotten the question before, but balls, they don't change. They're the same certificate, and you're absolutely right. However, if a drive goes bad, or if this sector that 1K file you wrote to is bad, and you lose it, or there's some corruption wrong with it, then you aren't going to be able to restore from any backup that has used that certificate. It is very, very important to back up your certificates. Like I said, small 1K files. If you back up your certificate and your private key every single night, that's 2K a night. If you went a month without cleaning up your data, you're at. That's not a big investment to be able to make sure that your databases are able to be used in multiple environments, that you can use your backup and restores the same way that you currently would use them. Advanced technologies, mirroring, log shipping, always on with availability groups. Anything that uses a restoring state database will have to have a certificate on both instances. If you do mirroring, you need to make sure that your mirror and that your principal have the same certificate. Availability groups, your primary and your secondaries. If you use log shipping, your primary and your secondary nodes in that as well. You need to make sure that they have the same certificates there for you to be able to use backup and restore technologies. How is performance affected? This is from the white paper on TV. Your numbers may vary. I have never noticed an increase. When I take baselines on systems, But historically, I've done this on systems that weren't very heavy OLTP systems. If you have a very, very heavy OLTP system, test in multiple environments. Make sure you have a rollback strategy. If your database server is like most others, where you're sitting with CPU around 20%, 5%, 2%, CPU is the cost. It's going to encrypt and decrypt those files as they're read off disk, as they're put into the buffer memory. So I would say that just be aware of this. Be aware of what your server is, know what your workload is, and use this cautiously. 9 times out of 10, you're going to be fine. Rare cases, you may see a performance increase. Self-managing certificates. Do not overcomplicate it. Plan to keep a copy of the certificate and the password on hand. Adhere to best practices through automation. Think of your current backup plan. If you've got a current backup plan for all your servers, all you need to do is just say, and now we have an extra step where we back up our certificates. Now we just use KeyPass and we make sure that we have the password for it. You don't need to overcomplicate this. Previous experience, in a one-man shop, I had over 35 prod TDE servers. I had the equivalent in staging, the equivalent in dev. I had kube servers, and I managed it just fine. That number starts to add up after a while. That's around 140 servers. You don't necessarily have to overcomplicate this. It's not that difficult to be able to track and keep track of. Now, the one thing is you want to manage realistic expectations. I worked in places where I had a security group that came to me and said, also, every year I want to be able to change the certificate. That's wonderful from a business point of view. You'd think it's just like changing a password. However, I always need to keep a copy of that certificate. Otherwise, I cannot restore backups from it. And there's going to be a period of time where we need to drop encryption and we need to re-encrypt using our new certificate. So anything can be done with this, but it's very, very important that you keep your business expectations realistic versus what it is that you've got to do every single day. So in this demo, I've got these scripts available. One of the things that I wanted to do for you is I wanted to just give you a couple scripts. What I would do when I was managing this is I would create a separate database on every instance that used TDE. I would have one table within that database that had a field for my master key and for my private key and have the passwords in there. I would use column level encryption on those, and I would have them encrypted by the certificate that I use for TDE, and then I would also put TDE on this database. This way, I would be able to call those passwords from this database using a user-defined function in a job, and I wouldn't have a password sitting anywhere in plain text on the server. So for this demo, I'm not using column-level encryption, but no, master key already exists. What I'm going to do is I'm just going to use regular transparent data encryption because demo-wise it makes a lot more sense. So I'm going to create a TDE DB. No, my NDF already exists. Let's go look at my data bin real quick. Probably got this sitting there from a previous demo. Let's delete this real quick. Okay. We'll create this database. And all we're going to do is we're going to create this one table, TDE keys, name, password, primary. Edit this how you need to, make it as secure as you need to for your auditors. I'm going to encrypt using this certificate. I'm going to set encryption on. I'm going to insert these values. Master key pass 1, Brad private key pass 1. And then I'm going to create my function. And all this does is just queries this table when I provide it with either master or private key to be able to get a password that I need. So now that that's there, this is a script that you would use to automate your backups of certificates. It's the same variables that I used before in the demo. And what I do is I just call this function right here to be able to get my password for master. and I use this function right here to be able to get this for private key. So if I run this, oh, transport level error cannot write. Oh, that's because I've already got a certificate in place. So that's another nice one. If you have a certificate backup, it doesn't overwrite with another one. So let's take our certificates real quick. Let's delete those. Let's run this again. If we check that backup then, you can see it ran just fine. Once again, this script is available for free, but this is just to help you automate the backups because there's not a maintenance plan in 2012, in 2008, or in 2008 R2 that actually backs up your certificates. And so this next script, all this script does is this goes through and I have to configure it a little bit. I have to put the path that I want it to look to be able to find the backups. And then I use like fields to be able to read all the data in, and I want anything that's like master database certificate. I read these into temp tables, and I basically say, okay, give me everything in here that's older than 4 days. I've got this field commented out, but this is where I would say, give me anything older than 4 days. This is the file count where I say, give me anything that's older than get date and delete it. This is just so that way I could run this and you can actually see this delete some information. I go into a loop, I provided all the things that need to be deleted, and I do it delete. I would throw this in a SQL agent job, and I would execute it right after my backups. Let's see if I take a look at my backups. You can see those certificates are now gone. Only my encrypted and unencrypted backup that we're looking at with our hex editor are still in place. That nice little transport level error is what happens when you restart your SQL service. You got to run the command twice before it opts on through. So those scripts, so that's everything you would need to manage an environment transparent data encryption. A script to be able to back up your certificates and a script to be able to delete the contents of the folders. I would normally take my backup folders, I would put data files, log files, and certificates. I would point to that certificate file exactly, and I would just manage them inside of there. So, as a reminder, I would just leave you with when data is missing or stolen, remember, you don't want to be somebody that ends up on this slide. And if you are in that situation, you want to make sure that you've done all the steps that you need to make sure that your data was not at risk. This is my resources page, SQLballs.com resources. Page row compression is what I've presented on the most, so that's why it's up at the top. But if you scroll down, you'll get to Transparent Data Encryption inside and out. And underneath there, you'll find the slide deck for SQL routing. This is up there as a PDF, and also the code is also up there. References. I point to Jasper Smith. He's a SQL MVP. He was blogging about what's new in SQL 2008 Transparent Data Encryption back when it was still Katai or whatever the code name was. Suntesh wrote the Database Encryption in SQL Server 2008 Enterprise Edition white paper. It's really, really good. If you plan on using it in this environment, I recommend that you go and you read it so that way when your boss asks you questions, you can answer them. The X.509 standard. If you have trouble sleeping at night, that's the encryption standard that will tell you all about what your subject does. Technic Transparent Data Encryption, that's where I got our nice little graph from when I talked about basically the encryption model of Taco 10 within Microsoft SQL Server. And DB data loss, that's where I got all of our data loss. And if we have any questions, please feel free to fire away.
We do have some questions. Jean would like to know what encryption algorithm you recommend.
I would say AES 256 currently.
Okay, awesome. Sakar would like to know, can we use TDE for SQL cluster?
Yes, absolutely. So the nice thing about a cluster is all of the data is consolidated in one place. It's on a SAN device. And while you have two instances that are clustered together, they use the same master database. The copy and the thumbprint of all the certificates that are registered with the instance are kept in the master database. So the nice thing about a cluster is it works just fine. You turn it on. There's nothing special that you have to do from one node to another. If you have 2 nodes, 4 nodes, 12 nodes, doesn't matter. You turn it on in one location, and you're good to go wherever you fall over to.
Awesome. Okay, UB-Stan has 2 questions. The first one is, does encryption reduce the size of MDF and LDF files?
If you're using backup compression, encryption will increase the size because backup compression only gets about only 1% of the compression you achieve without transparent data encryption.
Okay.
So backups tend to bloat it. Now the nice thing is encryption is completely compatible with page and row compression. And if you use page and row compression, you lower the volume size of data on your disk, that still translates in transparent data encryption. So that's the most effective form of compression once you put TDE on a database.
Okay, great. That's wonderful. The next question is, can TDE and compression works together?
Yes. Great question. Yes. Backup compression, you still get 1% saving depending on how big your database is. If you got a 100 gig database, you save 1 gig of space. 1 gig may matter to you. So I'd say, if it matters, put it in. Backup compression is going to cost additional CPU cycles. If the additional CPU cycles are not worth it or the space isn't worth it to save 1%, then I'd say don't use it. But page and row compression, absolutely. Use those in TDE. It doesn't change how they work at all.
Okay, great. We only have time for one more question, so it's going to be from Paul, and it is, can encryption be used within partition tables, and if so, is it recommended?
Absolutely, it can be used within partition tables. The big thing to keep in mind is it doesn't change how things occur in memory. It's only when it's read off a disk, there's a little bit of overhead as it. Once you get to an in-memory state, that's how SQL Server operates with everything. So if you have a very large memory and you have a large buffer pool and you're able to fit a lot of data pages in it, then it's not going to change your performance at all. The only way it would affect partitioning is if you have high CPU overhead and maybe you have a lot or an I/O bottleneck and you're reading a lot of stuff off the disk. You might see some overhead then. But if your server's working fine now, putting TDE on a partition table should not affect it negatively.
Okay, wonderful. Well, that was unfortunately all the time we had for questions. There were a couple more, and I will send you the full report, Brad, so that you can follow up with those as you like. And excellent. Thank you so much for such a wonderful session and for teaching me all about comic books.
You're welcome. Thank you.
And thank you, everyone, for joining us. Have a great day.